All right, so I'm ready for example number 2 using indefinite integrals. Now, again, it's an indefinite integral because there's no bounds. In this case, I wanted to make sure I pointed out to you that sometimes you can use u substitution, but on this question you can't. The reason being is if you use u for 1 minus x squared, the derivative of that is, negative 2x dx. The problem is there's no extra x up here. So there is not actually a du that I can use appropriately up here. It's just not going to work out nicely. So in this case, u substitution will not work. What I need to do instead with this problem is I actually need to FOIL it out, do the double distributive, whatever you want to call it. I actually need to perform multiplication with these two binomials before I can do anything else. And so if you think about it, 1 minus x squared squared becomes 1 minus x squared times 1 minus x squared. So we're going to end up getting 1 times 1, which is 1. X squared times, negative x squared times 1 twice. So we're going to get negative 2x squared. And negative x squared times negative x squared makes positive x to the 4th. All right, now that I've gotten that done, I'm ready to go ahead and do the antiderivative. I'm ready to go ahead and do the integration. So here's what I'm going to go ahead and do. So again, that 1 is going to become just a 1x. That's going to become negative 2/3 x to the 3rd. And that's going to become plus 1/5 x to the 5th. Now, the only thing that I haven't done yet, and I need to do because it's extremely important, is to remember, again, make sure you add in the constant of integration at the very end. Again, that's the most important step. The thing that people always tend to forget is that constant of integration at the end. So, again, it's just like performing a definite integral. Just make sure you don't have to evaluate anything. You just have to put the constant of integration, that plus c, all the way at the very end. Okay?